Okay, I'm going to demonstrate what we did yesterday, or what I did in the previous video. We created a heterozygous female for purple eyes. And we had two other traits on this chromosome that we were going to look at. And we were wild type for those. And we created this, all right, by crossing a heterozygous female and a wild type male, and we obtained our purple-eyed flies. And we're going to take this and we're going to cross it, all right. After we created this one, we're going to cross it with something like this. The male, of course, didn't have purple eyes. It was wild type. But it had some recessive traits here. It had like D, D, and B, and B. So it had two different alleles, and what we're going to do, there's only one chromosome to exist here and one here. So all of your children, without crossing over, should exist with just these two chromosomes if there weren't crossing over. You get one of these, and you get one of these. Now, if you'll notice, the plus is dominant over these, so your phenotype here, plus, which is wild type, and the little d, well, your phenotype is plus. Same here, plus and little b, your phenotype is plus, and p and plus. So all of your flies here that have these two chromosomes, all of them are what? Wild type. They show up as wild type. So if you cross two of these, all right, if you take these two and cross them, if there's crossing over, all right, you might actually get something to show up that isn't all wild type, and that's what we did. So we crossed two of these. I'll make another one, males and females here. And of course, if you cross these, all right, you should only get two combinations. You're going to get one with this one, all right, which is all right, and therefore you could cross it and get another one of these. All right, that was one possibility. Or you can get flies that have one of these, the one from over here, this first one, and one of these. Right? So I can mix this one and get it one here and one here. You could also get this one with each one. So they're the same. The only combination are these two, right? Well, you could get two of the. Sorry, I left one out. You could get two of this type. The D, B, D, B plus, plus. So what are you expecting? What are your phenotypes here? Well, this one would show you just P. That would be your phenotype with plus plus. All right, that's one phenotype. This one would be all pluses. So like this one. Draw it that way, I guess. All right, all pluses. And this one would be what? Just dB together. So it would be dB plus. I draw it like that. So one wild type, one that just has purple eyes, and one that has both of our mutants in it. And if you had straight Mendelian crosses, this is what you'd get. But that's not what you get. If you watched the previous video, you also got some others. You got, let me find my sheet here. I have them listed. You also got, besides these three, you also got just black, so just B, and you also got just D. So I believe when you count them up, you get 458 of these. All right, and you got purples. I think you got 231 of these. And then the doubles, you got 181. And these are what you expect. But you also got, up here, you got 53 of these. All right, and you got 67 of these. Now you'll notice these are smaller numbers than the ones you got down here. And so these are your crossing over events, and this is how you determine your mapping distance. Now I did 2 at a time, so you'll have to figure out how to calculate these with one cross. But this is how you look at this and figure out how to come up with your mapping distances. There are other ways, simpler ways, more difficult ways to do this type of analysis, but this is one where you can find your BD quickly, and you can look. Of course, you know your answers if you go look on the distances. The locations, so you kind of know what you're shooting for. You can do many of these over and over and add them together as a single cross. That will also get your numbers up so that you don't get quite so much variability, and you get closer and closer to the actual real number so that they're not quite as variable. Remember, the software does throw in some error to make it more realistic.